look up at the night sky, we might see a bright star moving steadily across the firmament. That's the International Space Station, or ISS, a symbol of human ambition and a home for astronauts orbiting our planet. But have you ever wondered how they survive up there, hundreds of kilometers above the Earth? How do they get food, water, or even a simple cup of coffee? The answer lies in missions like SpaceX's CRS-6, a journey that was far more than just a simple delivery run. It was a lifeline, a scientific enabler, and a crucial step forward for the future of space exploration. Imagine packing for a trip that lasts for months, but instead of a suitcase, you need to fill an entire cargo ship. That's essentially what the CRS-6 mission did. On April 14, 2015, a SpaceX Falcon 9 rocket launched the Dragon spacecraft, loaded with over 2 metric tons of essential supplies bound for the ISS. This massive payload included everything the crew needed for daily life. There was carefully packaged food to provide nutrition and variety, containers of fresh water, and essential personal items and tools. Every single item was meticulously planned and packed to ensure the astronauts could live and work safely and comfortably in the unique and demanding environment of space. Without these regular resupply missions, long-duration stays on the station would be impossible. Beyond just sustaining the crew, CRS-6 was instrumental in advancing scientific knowledge. The Dragon spacecraft carried a host of important experimental instruments and materials, transforming the ISS into a cutting-edge laboratory in orbit. These experiments were designed to help scientists on the ground investigate phenomena that are impossible to study under Earth's gravity. The cargo included hardware for research into cellular biology, which could lead to breakthroughs in treating diseases. It also brought materials science experiments, exploring how different substances behave and change in microgravity, potentially leading to the development of new, stronger, and more efficient materials for use both in space and on Earth. This scientific payload was a critical part of the ISS's primary purpose, to conduct research that benefits all of humanity. Like any complex machine, the International Space Station requires constant care and attention to keep it running smoothly. It's a sprawling, high-tech outpost that has been continuously inhabited for over 2 decades. And just like a home, things occasionally break or need upgrading. The CRS-6 mission played a vital role in this ongoing maintenance effort. Tucked away within its cargo hold were critical spare parts, replacement components, and new equipment needed for repairs and system upgrades. These items are essential for maintaining the station's operational stability and safety, ensuring that its life support, power, and communication systems continue to function flawlessly. Every resupply flight contributes to the longevity of the ISS, allowing it to continue serving as a beacon of international cooperation and scientific discovery. While survival and science are paramount, maintaining the morale of the astronauts is also a key consideration for a successful long-duration mission. Living in a confined space far from home can be psychologically challenging, and small comforts can make a world of difference. Recognizing this, the CRS-6 mission delivered a very special piece of equipment that generated excitement around the world. The first espresso machine designed specifically for use in space, dubbed the Espresso. This machine allowed Italian astronaut Samantha Cristoforetti and her crewmates to enjoy a genuine cup of espresso, providing a small but significant boost to their spirits and a welcome taste of home. It was a thoughtful touch that highlighted the human element of space exploration. The Dragon spacecraft's mission wasn't over once it delivered its precious cargo. After being berthed at the station for about 5 weeks, it was reloaded for its return journey. But this time, it was filled with the results of the crew's hard work. The spacecraft carried back valuable scientific samples from experiments conducted in orbit, including biological specimens and materials science results. It also transported equipment that had completed its mission and needed to be returned for analysis or refurbishment. This ability to bring cargo back to Earth is a unique capability of the Dragon spacecraft, making it an indispensable tool for researchers who need to study the effects of space on their experiments in terrestrial labs. Perhaps the most groundbreaking aspect of the CRS-6 mission was not what it sent up, but what happened to the rocket that launched it. On this flight, SpaceX conducted a daring and ambitious test. After separating from the second stage, the Falcon 9 rocket's first stage attempted a precision landing on an autonomous drone ship floating in the Atlantic Ocean. While the rocket did reach the ship, it landed hard and tipped over. Despite not being a complete success, this attempt provided invaluable data and represented a monumental step towards SpaceX's goal of developing fully reusable rocket technology. It was a bold experiment that pushed the boundaries of what was possible and paved the way for the routine rocket landings we see today, which have drastically reduced the cost of accessing space. In the end, CRS-6 was far more than just another launch on the calendar. It was a complex, multifaceted operation that touched every aspect of life and work aboard the International Space Station, from providing the basic necessities of life to enabling groundbreaking science and testing revolutionary technology. The mission was a testament to human ingenuity and our relentless drive to explore. It wasn't just a delivery, it was the very lifeblood that sustained an entire orbital outpost, ensuring that our quest for knowledge continues to reach for the stars.